CAISA is important in the history of TNO because it was just a drastic move from classical radar to new radar. It has all these innovations from the technical microwave stuff, from the computing, the digitizing side, the software side, and the operation and the human interface.
What CAISA does is create an antenna beam, a pattern, that can be electronically steered to different places in the hemisphere. So it can look at different angles. And that tried to find a solution to the increased threat of missiles by all kinds of hostile countries.
You have to imagine that in the 60s, 1970s, there were a lot of threats in the Cold War and a lot of quicker planes coming ahead to us. And then the government decided to try to find and make a faster radar that was capable of tackling all those threats that's coming at you. The normal radar was spinning around. And before you had a hit on the screen, then you have to wait another cycle to see that thing again. And then it moved farther away. Also, the airplanes going faster and faster. And then they discovered that you can electronically move the bundle, the sweep. And then you can target more objects.
This is one of the elements out of the CAISA array. And the phase shifting that creates the adjustable beams is performed by the ferrite rod inside that waveguide. You could say, well, those ferrite phase shifters are not employed in any of the systems that are currently in use by the armed forces. But they were an indispensable step to create the active phased array radar, the next generation, that is now abundantly in use by the Dutch armed forces. We're here at the Museum Waalsdorp, and for good reason. Because knowing your past means that you will better understand where you are currently, where you are today. And if you don't know where you are today, why you are where you are, how can you shape the future?
Now more than ever, we are aware of the relevance of our work. It is important that we continue to develop knowledge and technology to contribute to a safer world. When I was born, this was the technology available at the time, and now we are a few years further, and we have new technology now, but we are trying to solve the problem of today. A few months ago, we were discussing about hypersonic threats, something for the future, but that future is now, and we are working to develop innovative radar systems to address this problem and to find solutions that can cope with it.
My job generally is to look 10, maybe 15 years ahead, try to assess the threats of the future, and then I'm at the hardware side trying to create solutions that will be able to tackle those future threats. That's both super nice as well as very challenging.